Okay, this is a lesson on how to do simple differentiation, taking the derivative of some simple terms, individual terms. So if you have, first of all, the notation is either going to be f prime x or y prime or dy dx. They all mean the same thing. They mean you're taking the derivative. So if I have some sort of function, which is just a simple term, I want to bring my exponent down, put it in front, multiply by whatever's there, and then reduce the exponent by 1. So for example, if I have y equals 5x squared, it's going to be y prime, because it's y equals, and I'm going to take my exponent, multiply it by the coefficient, so 5 times 2 is 10, x, and then I'm going to reduce the exponent by 1, so 2 subtract 1 is just going to be 1, so it's just going to become 10x. If I have a larger one, I'm going to take each individual term and do it kind of one at a time. And it's f of x, so it's going to become f prime x equals, and then I'm going to multiply my exponent to the coefficient and reduce the exponent by 1. So multiplying, 4 times 3 is 12, x, reduce the exponent by 1, 3. Multiply and reduce the exponent by 1. So multiply becomes negative 6, reduce the exponent by 1, negative 6 squared. Multiply, reduce the exponent by 1, just 10x. Now here I have an invisible exponent of 1, so I multiply and it becomes negative 7, and reduce the exponent by 1 just becomes x to the 0, and then my constant of negative 3, it just goes to 0. I don't even have to worry about it. Okay? So here is the derivative. Each time I was just doing each term individually. Sometimes you have to do a little bit of work to the terms. You have to get it so you have an exponent. So you notice in the second term I divided by the square root of x. Now the square root of x is equal to x to the exponent 1/2. Okay, that's what it is written as when it's in power form. And the 1 over means it's on the denominator. So that means it's going to become 1 over. So 1 over the square root of x is actually equal to x to the negative 1/2 when it's written in exponential form. Okay, so I'm going to write that so it's all in exponential form first. So each term has an exponent on it. So 4x cubed minus 6 times x to the negative 1/2 plus 7. Now I can follow the rule of multiplying my exponent to the coefficient and reducing the exponent by 1 to find the derivative. So it becomes 12x squared. Now I'm going to multiply. Okay, so it's negative 6 times negative 1/2 is positive 3x. Reduce the exponent by 1. Negative 1/2 subtract 1, which is negative 2 over 2, becomes negative 3 over 2. So the exponent is negative 3 over 2. And then my constant plus 7 just goes to 0. Now sometimes you can leave your exponent as a negative, other times you cannot. If you cannot, you need to take it back down into the denominator. Oh, sorry, plus 3 over x to the 3 over 2. Okay. Here I have, again, I got terms, kind of two terms on top being all divided by 3x. I need to do a little bit of work to get them so they're all just individual terms. I'm going to divide both those terms by the 3x and subtract my exponents as I do it. So my function can be rewritten. Divide, subtract exponents. 9 divided by 3 is 3. X squared divided by x is just x, so 3x minus divide 4x squared. Now that I have it down in as individual terms, I can actually take the derivative of this. So my derivative, subtract exponents, multiply and then reduce exponent by 1 just becomes 3 minus multiply 8x. And there's the derivative of that. So this is a quick lesson on simple differentiation. You bring your exponent in front, multiply it, reduce the exponent by 1. Thank you very much.